Welcome to you all in the ongoing discussion of physics tutorial problems. So far I have been displaying the PDF of statements and problems and solutions with a background voice video. From now onwards, starting from physics problem 31, I am directly appearing on the board and solving the problems for you. For the time being, I am using only a conventional board, so a conventional whiteboard for discussions. So later on, maybe we can improve the provisions. Today, the problem which I am going to discuss is already on the board. You can see 3 pulleys are present and 2 blocks are present. So when we release the system, what will be the ratio of the 2 accelerations? So this block A, block B, acceleration ratio we want to find. So accelerations depend on displacements, distance mode, that is proportional to the distance mode. So this acceleration of A depends on a certain distance, acceleration of B depends on certain distance. The distances must be measured or marked from certain reference level. That reference level must be a fixed level. So as you can see, the ceiling is a fixed level. From there we can mark the distances. That is one option. But better option will be to take this center line of the pulley, upper pulley, as the reference line. So we will take this as the reference line. Reference line. From that reference line, we mark the distances. This acceleration of A depends on this distance. Say we mark it as x. That distance. Acceleration of B depends on the distance below, up to, from the reference line up to this distance, up to m. Up to m theoretically, but for convenience sake, we fix it at this level. Up to the center of, because this center of the pulley and this mass has the same acceleration. So we mark that distance as y. We now mark the accelerations as A1, A2, like that. A1 we mark it like this, A1. A2 we mark it like this. This point also will have the same acceleration A2. Now A1 will be, now we use a little bit of calculus now. That is, second derivative of the displacement is the acceleration. First derivative will give you the velocity. Second derivative d2x by dt square will be acceleration. That acceleration we mark as x double dot, because second derivative mark as x double dot. So it will be this x distance, x double dot, d2x by dt square is A1. Likewise, this A2 will be y double dot, d2y by dt square. That we take note. Then there are two strings involved. The strings are assumed to be inextensible. Inextensible means in the process of the system moving, the string length will not change. That is the string length constraint. It's a constraint. Based on that only we have to get this required ratio. So upper string as the length, this length plus this. So one more distance we have to mark. It becomes clear that one more distance we have to mark, because this length will depend on this variable length also. Variable length from here to this. That length also is involved. So I will mark it as another symbol I will give, Z. Although Z will not be involved in our answer, but we have to make use of it. So upper string, length of the upper string is upper string length is equal to x plus z. X plus, both are variable. When the system moves, both will change. X then, but x plus z should remain constant. So x plus z is constant, which implies x double dot plus that. You differentiate once, x dot plus z dot, constant differential is 0. So it becomes, and we differentiate again twice. So x double dot plus z double dot is 0. Differential coefficient is 0 for constants. Now lower string. Lower string is, this is the string. From here, starting from here, it goes up to that. Wherever the variable portions are, this portion is variable, this is variable, and this is variable. So this portion has the length equal to we have already seen that the upper string has length x plus z equal to constant. It implies x dot plus z dot equals 0, or double dot we put, will be 0 also. That is our first equation. Now the lower string. It has 3 sections, x minus z, y minus z, plus y. So x minus z plus y minus z plus y equal to constant, which you can further simplify as x plus 2y minus 2z equal to constant, which on differentiation twice gives us x double dot plus 2y double dot minus 2z equal to, so the double dot equals 0. From this, as I told you, we have to eliminate the z, which is not required in our answers. So to eliminate z, I will double this, 2x double dot plus 2z double dot equal to 0. So on addition of the two equations, we get 3x double dot plus 2y double dot equal to 0. Now we substitute the original symbols. X double dot is a1. So this implies 3a1 plus 2a2 equal to 0. So that is the relationship between the accelerations that we are looking for, which you can write as a ratio as a1 by a2 equal to minus 2 by 3. This is the relationship that we require. A1 by A2 equal to minus 2 by 3. the numerical ratio between the acceleration is a1 by a2 is 2 by 3, whereas this minus sign indicates an important, that gives us an important information about the system. That is, I have marked, for convenience sake, I have marked both a1, a2 downwards, whereas a minus sign now tells us that a1 and a2 can't be both in the same direction. If a1 is down, a2 must be up. Likewise, if a2 is down, a1 must be up. So that is indicated by this minus. So when you really work out for the actual accelerations, we can remark one of them as you take it as it is, the other one you reverse. Or you can use this modulus 2 by 3. a1 by a2 modulus is 2 by 3. So a1, a2 ratio between the two is 2 by 3. That is the ratio we want, accelerations. Modulus ratio is 2 by 3. Now when you really work out the problem, you can reverse, as I said, you can reverse one of the accelerations opposite to the marked direction, and we can proceed further to get the actual accelerations. I will further discuss this problem in our next class also. Okay, thank you for the time.